Welcome to Radical Expressions and Rational Exponents. Today's objectives are to rewrite radical expressions by using rational exponents and to simplify and evaluate radical expressions and expressions containing rational exponents. In the past, you've become familiar with finding square roots. If I ask you to find the square root of 16, you try to think of what number multiplied by itself will give you 16. Now you know that 4 and negative 4 are square roots of 16. The concept is similar for any other type of root. So if I wanted to find the fourth root of 81, you think of what number times itself 4 times gives you 81. And the answer ends up being 3 and negative 3. Or you can write that as plus or minus 3. And the reason for that is 3 times 3 times 3 times 3 gives you 81. But also, if you did negative 3 times negative 3 times negative 3, you'd have 9 and 9, and those two together would be 81. So one thing we'll notice is if it's an even number root, you can have a positive and a negative. But let's talk about odd number roots. So for problem B here, we're finding the cube root of negative 125. So the answer to this is negative 5. And that's because negative 5 times negative 5 gives you positive 25. And then positive 25 times negative 5 is negative 125. Now it can't be plus or minus 5, because if these were all plus, if I did plus 5 times plus 5 times plus 5, I'd have positive 25. So for even roots, it's a positive and negative. For odd roots, it's either or. So it's either positive or negative. Okay, let's look at problem C. So problem C is the sixth root of negative 729. So it's an even number, so I know it's going to be positive or negative. And the answer is 3. Now, how did I figure out what that number was? That's something we'll discuss furthermore in the video, but for now, I want you to know the difference between even roots and odd roots, and to know whether the answer can be plus or minus, or just one or the other. In algebra, we learned two properties of square roots. We learned the product property and we learned the quotient property. Now, even though we learned these originally for square roots, this works for any type of root. So when I say nth root, it means it can be any number. It can be the third root, it can be the fourth root, it can be the fifth root, and so on and so on and so on. So when we say nth, we can basically replace that n with any number. So for example, here's an example of the product property. Let's say I was trying to figure out the cube root of 16. Well, we know there are two numbers that multiply together to give you 16. We know that 8 times 2 gives you 16. But here we're not just talking about 16, we're talking about the cube root of 16. So it has to be the cube root of 8 times the cube root of 2 equals the cube root of 16. The product property is helpful because now we can simplify this radical. The cube root of 8 is a number that multiplies by itself 3 times to give you 8. That number is 2. Now you can't simplify this second one, so your final expression is 2 times the cube root of 2. Now the quotient property deals with fractions. So let's say we were doing the square root of 25 divided by 16. What the quotient property says is we can break this into two fractions. So what we're going to have here is the square root of 25 over the square root of 16. And that's easy to work with. You know, the square root of 25 is equal to 5. And the square root of 16 is 4. Let's use those two properties to simplify the radical expressions. Let's look at example A. So, what we want to use to simplify this is the product property. Now, what does the product property tell us? It tells us that we can take this expression and break it down. So we can do the cube root of 27 times the cube root of x to the 6. Now we know the cube root of 27 is 3, but the cube root of x to the 6, we want to break that down a little more. So what we'll do is, we'll do the cube root of x to the third times the cube root of x to the third. Both of these multiplied together would give you x to the 6, so we're good. Now the cube root of x to the third is a little easier to figure out. What value do we have to multiply by itself 3 times to get x cubed? And that value is just x. So it's x times x, so you have 3x squared. Okay, let's do a few practice problems. So for these two, these will both be product property. So the first one, we'll break that down into the fourth root of 16 times the fourth root of x to the 4. So the fourth root of 16, that's just 2. And the fourth root of x to the 4 is just x. Which makes sense, because that means if I did 2x raised to the fourth, I would have 16x to the fourth. So this is our answer. Now for the second one. So now we kind of doing the reverse of the product property. So we're taking these two and we're going to multiply them together. So we're going to combine them. It's kind of like the reverse product property. So we have one radical, the cube root of x to the seventh times x squared. Now we know from our exponent properties that if we're multiplying two bases that are the same with exponent values, we add the exponent values. So I have the cube root of x to the ninth. And the cube root of x to the ninth is just x to the third. Which makes sense because what that's saying is, if we did x to the third times x to the third times x to the third, we would just add all those. So it would be 3 plus 3 plus 3, which would equal 9. What we're used to seeing so far is some base raised to a regular exponent. This here we say it's x raised to the 4. In this section, what we're going to get used to seeing is rational exponents. So for example, we could have x raised to the 1 over 2. Now this we say x is raised to the 1/2, but we can also say that x raised to the 1/2 is the same as taking the square root of x. These two are equivalent statements. So even saying x raised to the 1/3, that's the same as taking the cube root of x, and so on and so forth. X raised to the 1/4 is the same as saying taking the fourth root of x. So if we ever have some term raised to 1 over n, we say we're taking the nth root of that term. So sometimes we'll see them as being raised to 1 over n. Now other times we may see it as x raised to the 3 over 2. Now what this means is x is being raised to the 1/2, and that's being raised to 3, which is the same as saying we're taking the square root of x and then cubing it. So for example, if I said I was going to take 8 and raise it to the 2/3, that's the same as saying 8 to the 1/3 squared. Now we know that raising something to the 1/3 is the same as taking the cube root of it. So here we have the cube root of 8, which we know is 2, squared is 4. So we're used to seeing exponents like this. In this section, we're introducing raising an exponent to the 1 over n, and we're also introducing having an exponent being raised to an m over n, or some type of fraction. So these are the new ways to raise a base to an exponent. let's use that idea to write these expressions in radical form. So the expression we want to work with is negative 125 raised to 2/3. So I want to break up that exponent. So what I'm going to do is I'll have negative 125 raised to the 1/3 squared. These are still the same terms. Now I know raising any term to a 1/3 is the same as taking the cube root of it. So I have the cube root of negative 125 squared. The cube root of negative 125 is negative 5, but I still have to square it. And negative 5 squared is 25. So we wrote it in radical form, and then we simplified. Now let's write some expressions using rational exponents. So we're going to write each expression using the rational exponents involved. So I can rewrite A using rational exponents. So I know that taking the fourth root of something is the same as taking that same term and raising it to the 1/4. Now what I want to do with that after I raise it to the 1/4 is distribute it to here. So my final term is going to be 7 raised to the 3/4. Now sometimes you won't be able to simplify anymore. But in other examples, for example in B, where we take this and rewrite it as 11 raised to the 6 raised to the 1/3, when we distribute that 1/3 through, we have 11 raised to the 6 divided by 3, which is 11 squared, which we know is 121. So sometimes you'll have examples like this where you can't simplify. Other times you'll be able to simplify the expression. Now when we're simplifying expressions, we want to think about all of the exponent rules that we've learned in the past. So for example A, we have 25 raised to the 3/5 times 25 raised to the 2/5. So think about this as regular exponents. Let's say we had x raised to the 3 times x raised to the 2. We know that x and x are the same base, so all we have to do is add the exponent values. Same thing for rational exponents. Here we have 25 raised to the 3/5 times 25 raised to the 2/5. Since these bases are equal, all we do is add the exponent values. So it's 25 raised to the 3/5 plus 2/5. This is easy because they have the same denominator, so we can add them. So it's 25 raised to the 5/5, which is the same as 25 raised to the 1, which is just 25. So use the same exponent rules you learned in the previous sections. So for letter B, we have 8 raised to the 1/3 divided by 8 raised to the 2/3. Now here, if we have two bases that are the same, raised to two different exponent values, we subtract them. Same idea here. Here our two bases are both 8, so we do 8 raised to the 1/3 minus 2/3. So our final answer is 8 raised to negative 1/3. Now this isn't simplified because we have a negative exponent. So what this becomes is 8 raised to the 1/3 under 1. We know any number raised to the 1/3 means taking the cube root of it, and the cube root of 8 is 2. Alright, that's the end of our video. Thank you and take care.